In the past, we've talked about simulation tools and we have talked about tolerance analysis tools. But have we talked about them together? Let's talk about Enventive next. All right, so we know that for mechanical design, tolerance stackup analysis is really important. You specify variation within individual components, you roll that up to an assembly and see what the impact will be, because you might have a whole bunch of parts that are conforming, but when you put them together, they might not overall. So that's important for quality and manufacturing, but it also has an impact on performance, say structural analysis and other types of things. And this is where Enventive can really make a difference. So how exactly does it work? So you start off either by bringing in a 3D model from your CAD application, or you can actually do sketching and developing geometry directly within Enventive. Once you have that definition, then you can add the variability that you have on measured dimensions, as well as any loads and constraints and the other typical things that you would do to set up a structural analysis. Then you run the analysis. And not only do you get insight into the impact on conformance to manufacturing specifications like the tolerances, but also you gain an understanding, or you get insight into the performance of that design over the range of variation. So why is this a big deal? There are lots of tools out there that are good for validation of decisions. You look at lots of analysis tools out there. There are lots of good tools for documentation of the design, right? So once you have a full 3D model, okay, now you can accelerate how quickly you can create documentation and use that for productivity. There are some tools out there that will help with design decisions, and this one falls clearly in that category. Although you can use it for validation too, but the big difference here is that you can use it for decision making. You can insert variation into your design. You can see how it affects manufacturing in terms of conformance. You can understand the impact that it has on performance in terms of structures and other types of engineering physics. So in this way, it really is a pretty important tool, pretty important capability, because if you don't get the design right, it's gonna affect you sooner or later in the development process, whether it's prototyping and testing or getting to manufacturing and what have you. So this is a tool that's really different. I haven't seen this mix of tolerance stackup analysis and performance analysis in terms of structures. And it really can have an impact on making better designs. That's it. Take care and talk soon.